Hello and welcome guys to the third and final video of the series of AI security risks and frameworks where we cover our Databricks AI security framework. So we covered some of the risks, we covered some of the explanations of what AI and AI security is, what it entails, and then we're just kind of covering some of the risks. So last video series we ended on training data poisoning. So now we're going to cover some of the prompt injection risks. Where does it sit? How we mitigate it, and what we can do about it to prevent certain risks materializing in our AI model development. So let's dive right in and look at how we can mitigate prompt injection, what it is, and how we can prevent this from occurring in our workloads. Hopefully you guys learned something in the last two video series and you're going to stick along with us as we cover the last remaining slides, and we're going to just talk a bit about AI security risks. So as we can see guys, you've seen this slide previously, all of the AI system components, but we're going to cover now where does prompt injection lie in our framework, where does this risk can materialize, and how we can prevent it from becoming a problem in our model serving. So prompt injection essentially is the type of risks we covered in the first video series about some prompt injection attacks that Chevrolet suffered in their model development and serving to their customers. So we're going to dive right in. So let's I guess, guys, if you want to have a think about, pause the video and think about where can prompt injection attacks could happen in the first place in this model. Have you done it? Have you found it? So let me showcase, guys. Prompt injection happens in the 9th step, so where inference happens. So prompt injection risks essentially could happen in our model serving essentially architecture, where we essentially embed and allow customers to interact with our model. So that's where prompt injections happen. Now, how do we prevent such risks and what it essentially is? So let's have a look at the next slide. So prompt injection risk overview, essentially the risk, how it materializes itself is essentially it's inserting a prompt to manipulate the normal behavior. So you can fool a machine learning system by providing malicious input with adversarial examples to make a false prediction. You can essentially, what it can lead to things like leaking trade secrets or credentials from training data, or by acting on internal systems. You can make LLM do remote code execution or perform actions on external systems that were not intended. So let's explore some of the best practices to mitigate those risks. So you can protect and enforce access controls to ML and LLMs via API endpoints. You can use Secrets Manager to protect credentials. You can segregate backend internal systems from LLM access. You can implement ML ops with human in the loop. So we looked at that in our previous videos as well. And you can implement gates between users and callers and use the actual model by performing input validation, post-processing on all proposed queries, and returning the minimal viable needed essentially answers. So there are tools now you can embed. There are specific AI firewalls that help you to do this input validation, or you can do specific ways in your platforms. But I think that the key point is essentially strict access controls. You can implement ML ops, with actually embedding human in the loop. It's very important to use Secrets Manager to protect your credentials, and obviously you need to segregate backend from front-end systems. So let's look a bit about where do these controls lie in our model. So as you guys can see, is prevention is much harder than the risk, because obviously risk itself materializes only in one place. But in order to actually protect the whole system integrity, we need to build controls across various states within our model development. So as you can see, where we use secret managers to store credentials, We have to prevent access to the internet for LLM models, where we embed MLOps with human in the loop to make sure we have someone verifying what the model is doing. How do we prevent internal systems access from LLM models, how we can monitor interference with responses, how we do IP access lists and private links, model gateway as well. And as well as I mentioned earlier, guys, you can deploy things like AI firewall. So these are some of the things that you guys have to think about and weigh up as options to prevent prompt injection. I want to caveat here, it's important thing to guys to understand that, most of these controls, is going to be very important, but sound security controls is always risk-based approach. So you will have to define and agree with business stakeholders which ones will able and allow you to mitigate the highest level of risks, and which ones will be deemed acceptable spend to mitigate that risk. Risk is always about, sort of risk mitigation is about, risk versus reward. So how much we need to spend to mitigate specific risks. So, we will cover a number of risks here, but, not necessarily all the controls will be essential to mitigate that. But we have to be mindful of what are the potential dangers and how we can mitigate that, and how do we protect our business integrity, our business reputation, and potentially, financial losses that can happen via serving AI models. I'll talk a bit about later, but there's certain things that need to be considered and certain things that need to be weighed up, and it can't just sit within engineering or within a specific department that's just building AI models. As I mentioned before, always some of these slides obviously are added with specific Databricks controls. So those of you guys who are actually using Databricks frameworks, but I wanted to highlight, you don't necessarily need to be on a Databricks platform to leverage and think about specific controls. So previous slide shows generic controls, where this shows specific Databricks platform controls that you need to establish in order to mitigate those risks. Now, let's explore some of the, wider controls that we can look at for prompt injection. So as you can see, obviously, this again is highlighted specific risks from Databricks security framework. You have, SSO with IDP and MFA to limit access, sync users and groups, restrict access using IP access lists and things like that. So some of these risks are obviously specifically, again, tailored to Databricks platform, but most of them are going to be overarching controls that we need to think about how we can protect our models. Again, how we can secure model serving endpoints, control access to models and model assets, how we can restrict things using private links and things like that. So all of these things are considered risk mitigation tactics to prevent prompt injection. Now, if we move into the next risk, we're going to discuss the model theft. Again, model, organizations are currently now deploying and building their own models. They're fine-tuning the models. Obviously, models have a way of becoming your proprietary or intellectual property, especially, there are plenty of organizations in quantum trading houses who are, guarding their models as a very important secret, because that's their competitive advantage. That's how they are making trades and making business. So, depending on your use cases, models will become the most important intellectual property in the near future as you gain competitive advantage against your peers and competitors. So let's have a think about where does the risks of model theft can appear in your model diagram. So again, guys, if you want, pause the video, but think, where can model theft can happen? So as you can see, guys, again, model theft can happen in a number of places, including, input control resources, black box attacks, infer training data membership, model inversion, and the model theft. So there's going to be a number of risks, and there's going to be a number of controls that we need to think about how we're going to mitigate those potential risks. But as you can see, again, guys, depending how we're going to set up serving infrastructure and serve the model, there are a number of risks that could materialize, and we need to think about how we can prevent those risks from materializing. What mitigation tactics do we need to deploy? And we need to also think about costs, and we need to raise those concerns to the business executives to make the decisions of how we're going to do that. But again, I think, I'm going to mention again and again, I think you as security leaders within your organization, you have a way to be the leaders of adopting AI, but making sure that we can highlight specific risks and making sure that we adopt safe AI uses in our organization, and we become the leader, the proprietor of AI in our organization. So these are the risks. Now let's have a look at the risk overview. So essentially it's unauthorized access to and exfil of models. So you can have an unauthorized access to model serving endpoint. You can steal model artifacts by, leaked essentially by insider. Attacker can craft inputs to collect model outputs. And also attacks can happen to extract sensitive and confidential information from ML systems that was used for training. So now some of the best practices of how we can mitigate that: we can enforce strong access controls via network allow lists and role-based access authentications. We can implement rate limits and API calls. We can use least privilege to control access to ML artifacts. And we can secure model serving endpoints to prevent access and compute theft. We also must encrypt model artifacts both at rest and in transit. And also we need to monitor and audit access to essentially to our models and to inference architecture. So that's essentially, the risk overview and the best practices to mitigate. Now, if we go to the next slide and have a look where we can deploy those controls that we can mitigate those risks. So as you guys can see, again, we can authenticate and authorize model operations. Again, we can use ML ops with access control lists, logs, and encryption. We can also, again, use IP access lists, use private links, use model gateway, and some of these, the most important controls to mitigate and prevent model theft. Now, again, depending on where you guys going to serve and what use cases the model is going to have, if we're talking just a simple chatbot, model theft will be a limited risk. But as I say, depending on specific use cases and how the business drives value generation and generates revenue, if model is your main way of generating revenue, now that's going to be the most important intellectual property. So you need to think of ways and scenarios how you can prevent model theft. So something for you guys to consider. I'm just going to quickly show again. The Databricks controls are very similar to what I've just showed, specific to Databricks itself platform. You can again have Databricks mitigation controls, again similar to ones I've showed you previously. But now we're going to dive in right into the next control, which is backdoor machine learning and essentially a Trojan model. So I think important thing to highlight, as I sip my coffee, is that I've seen, and obviously the proliferation of models and open source models around the internet, especially people using things like Hugging Face, Kaggle. Now there is loads of open source models that you can use for various applications. Now, but the problem is, some of these models have a backdoor in them. They have essentially they've been modified either to steal your proprietary data, to skew the results and things like that. There's a certain number of things can happen if you're just going to drop an open source model in your production workload. So there are ways to mitigate those risks. There's ways to test the models that make sure they haven't been tampered, check the integrity across various stages of your model deployment. So this is, as this AI adoption rate grows, some of these risks gonna obviously increase and become much more important way to address and think about. There's so many bad things can happen, especially if you drop a production workload with a specific model that has potentially been backdoored, and so many things can happen. So you need to make sure you have checks and balances that can prevent this from happening in the first place. So again, same thing, AI system components. Where do we think the risks of backdoored or Trojan model can appear in this diagram? Again, if you want, guys, pause the video, have a look, have a think. Where could we expect specific risks to materializing? And I'll jump to the next slide. So the risks can happen essentially mainly where we store our models. So we have ML supply chain vulnerabilities and we have backdoor machine learning Trojan model risks. So these are the two main risks that could materialize in the model, in AI framework, the way we're developing our AI models. So let's have a look at this whole risk overview. What does it mean? What's the ML supply chain? What's the backdoor and Trojan model? So essentially what the risk is a potential malicious pre-trained models in our supply chain. So there are inherent risks when using public ML or LLM models or outsourcing their training. An adversary can deploy malware through a pre-trained ML model as a hidden backdoor, allowing them to manipulate the model's output, trigger specific actions, or even steal sensitive data, as I mentioned before. So there are ways we can prevent this from happening, and the best practices to mitigate those things are, using access control lists again to limit who can bring models and limit the use of public models. We need to evaluate the models and validate, aka stress testing, to verify reported function and disclosed weaknesses in the models. We need to register, version, approve, promote, and deploy models. We need to build models with all representative, accurate, and relevant data sources to minimize third-party dependencies for models and data where possible. We also need to scan third-party models continuously to identify hidden cybersecurity risks and threats such as malware, vulnerabilities, and integrity issues. And we need to always think that models should be considered as untrusted unless they've been tested and verified. So I think the important thing is, I know sometimes we often talk about these, swear words in cybersecurity such as zero trust and things like that. But, zero trust is not a tool. Zero trust is a thought, how we should approach these risks and how we should think about, we should never inherently trust anything that's open source. So we should test, verify, and confirm that these models can be used in our internal workloads. So let's have a look at some of the mitigations or some of the controls that we can deploy to prevent those risks. So again, we need to scan third-party models continuously to identify hidden security risks. If you guys explore, there are even now papers where people have developed specific LLM models that allows you to scan other LLM models to discover any potential risks. You can evaluate, stress test, and red team your models. You need to authenticate and authorize model operations. So again, you need to make sure you authorize specific, pipeline deployments. You need to have two-person control checks and things like that. You need to make sure you have model management and approvals. Nobody can just simply deploy a model. Somebody should be double checking and approving the model deployment. Deploy models with multiple layers of isolation. Again, you need to control access to data and other objects. You need to build model gateways, again, IP access lists and private links and things like that. So you guys need to think about, again, how models appear in your model library, how they're being trained, what data using, how we preventing things from happening in the first place. Sometimes it's not only about having a robust tool set. It's about just building correct business processes. It's about always people talking about deepfakes, how deepfakes are a scary thing, but sometimes deepfakes are successful just because we bypassed business processes. I think we as security professionals sometimes too often rely on tool outputs and we just end up firefighting. So I think it's a very important thing to think about how we can build proactive, robust business processes that will prevent risks from materializing in the first place, and who actually will do a root cause analysis when something bad happens, why it happened in the first place, instead of just waiting for toolers to say this is misconfigured, fix it. So I think it's important to think of how we inbuild proactivity, how we can think and uncover those risks and how we prevent them in the first place, and how we actually build and design robust zero trust systems that removes inherent risk that's there. So something for you guys to think about, but some of these main mitigation controls to prevent Trojan models in our environments and systems. And as I always show again some of the controls that we can showcase from Databricks platform itself, and then some of the obviously Databricks mitigation controls that you can deploy in Databricks platforms itself. Now let's look at the last risk from our top 5 categories. So lack of trustworthiness. Now, when we always talk about AIs, and AI specific models, we often refer to AI as a black opaque box that it's inexplicable and untrustworthy because we can't quite understand how it arrived to a specific answer, or you can't explain how it arrived to a specific answer. Or secondly is, whenever you ask AI same question twice, you might get different answers because all it does is just predicting the next word in a sentence. And I think that's a very important thing for us to understand, how we can potentially uncover some of the trustworthiness problems in our models, and how do we need to go about to try and mitigate some of that. So let's look and explore what it is. Firstly, let's overview the risk and see what controls we can deploy to potentially look and mitigate some of these risks. So again, when we look at AI system components, same graph, have a think, guys, where do you think we could see trustworthiness risks materialize themselves? If you want, again, as I said before, pause, think about, is the goal is, it's not cheat sheet. It's for you guys to make sure that you guys understand what I'm talking about. Why do we arrive at specific ideas that we arrived at, and why are the risks materializing in certain places and they're not in certain other places? It should be a learning curve for you guys, how you can leverage that knowledge in your organizations. So when we look at lack of trustworthiness, we're talking about data legal risks, we're talking about stale data risks, we're talking about lack of data trustworthiness itself, we're talking about insufficient data lineage, we're talking about missing data classification that can exacerbate some of these risks, we're talking about lack of traceability and transparency of model assets, we're talking about model lifecycle without HITL, we're talking about lack of audit and monitoring in inference quality, So these are some of the main places where trustworthiness risks could appear. Now, how do we go about fixing that? Because obviously there's quite a few risks in here, and obviously some of these risks obviously are interchangeably, and some of these controls are interchangeable, and they combine together to solve some of the more prominent risks. But let's have a look and explore it a bit further. Now, lack of trustworthiness, essentially what it is models aren't reproducible or aren't explainable. So models are not reproducible, models lack explainability. Insider introduces a public new dataset that might be causing data-borne risks to model quality, and results are not consistent and or are biased. So now, this kind of thing becomes a bit more opaque, and that's why I wanted, I guess, guys, for you to dig a bit deeper, and I'll show you another framework at the end, which I'm using currently as well. But I think the problem we're currently having, because AI model development crosses a number of boundaries, and that's not necessarily, I think, could be contained within security. Because when we're talking about trustworthiness problems, not all of them could potentially be security problems, because if results are not consistent or biased, it's hard from security engineering point of view to think about how this could be prevented or how could this be improved, because it becomes a wider business decision. That's why I think, for example, I always say AI development shouldn't be just left in engineering hands. That's why organizations are building AI ethics committees. They are building AI committees that needs to think about how we can protect and detect bias. How can we improve trustworthiness and transparency? How do we showcase that, because I think that inherently what we talk about, whenever we talk about AI models, customers might be reserved against using AI. They could be not trusting it. So we need to do our most and our best to improve trustworthiness. We need to make sure that we remove the bias from our data and from our models, and we can explain how our models arrives to specific decisions that they make. And this is not an easy task to adhere to and complete. So I think that's why we need to think about best practices. We need to think about how we adopt this organizationally and how we build checks and balances that will prevent some of these risks from materializing. So some of the best practices will be to enforce data versions and lineage, to trace the training data provenance, govern and tag data and features. We need to use systems to track and reproduce the training data used for ML model training, as well as identify ML models and runs derived from a particular data set. So again, you need to have lineage between what specific data has been used to that specific training model. And when you test for example, transparency or bias, you can compare specific data sets and how a model, arrive to their decisions. You need to implement ML data science code in a packaging, reusable and reproducible way, as a packaging with artifact versions and human owners for explainability and ownership. You need to craft different models via separate training data or fine-tuning for different use cases to create a more granular and accurate generative AI. We need to implement MLOps with human in the loop for RLHF and accountability. And we also need to add toxicity and bias prompts to test our models. So these are just some of the best practices. Now let's have a look at the controls that we can deploy in our model graph. So we are talking about, again, some of the things that we can, some of the controls that overlap with specific other risks, but we're talking about data versioning, access policies. We're talking about access controls, lineage of data. We're talking about data classification. We're talking about, automatic schema, quality and integrity checks in our data and access policies. We're talking about data versioning and governance. Again, we're talking about authenticating and authorizing model operations. We're talking about model gateways, IP access lists, private links, and all of that jazz that comes and make sure we remove lack of reproducibility and trustworthiness risks in our system. So have a think, guys. If you're part of the organization that currently is building any of AI models or is building and serving AI models, have a think. Have you guys addressed some of these risks? Have you addressed some of these controls in your model development? Think about how you can highlight and how you can become a champion for making sure that your models are trustworthy, and how we can essentially, potentially win more customers by showcasing what kind of great, reproducible and trustworthy models we are building, so we can explain how we arrive at specific decisions. Again, we're talking about Databricks controls in here. We're talking about Databricks mitigation controls based on specific risk framework. Now let's look at top risks from organizational point of view while building AI. So we're talking about talent, we're talking about operating model, we're talking about change management, decision support. The risk areas exist pre-AI? Of course they did. But is there a risk bigger than the business not realizing outcomes from data plus AI? So let's explore and dive deeper in some of these risk areas regarding from an organizational point of view. So when we're talking about talent, should any roles in the CISO org be AI specific? If so, which ones do you guys think? The landscape is a bit changing, and I think that's what I'm saying. I'm covering some of these learning materials, and even though some of the risks could be derived and understood from general security practice point of view or from engineering point of view, we'll need an elevation of skills in AI field that not necessarily we have a specific AI roles, but I think we keep talking about people fear that AI will replace people. I'm not necessarily think that it will do. In some areas maybe, but not necessarily in security. But I think what we need to do is some of the roles in especially maybe in security engineering will need to elevate their skills to understand how to mitigate AI security risks. How do we work with other departments and business units to uncover transparency, mitigate prompt injection, mitigate all of the other risks, and how we can help businesses leverage the AI to the best of their capabilities while limiting risks and exposure. How do we can source AI skilled talent, and how do we help your talent to learn AI? So I'm hoping to highlight some of the material. There are courses coming out regarding specific areas in AI, how we can learn. There are places like Google has some amazing playgrounds where you can work and interact with various AI development models, and you can learn how to essentially secure, how to change models. You can use Google has Google Colab, where you can build and train and fine-tune your models, where you can learn. Google exposes various playgrounds. You have things like Kaggle, where you can test and look at the models. There's various playgrounds popping up where you can actually look a bit deeper under the hood. But I think the main way to build skills and collaborate is looking at research papers, looking at and experiencing some of the AI security companies and security vendors, what they're doing. It's probably not straightforward yet, but I'm sure the talent and the training need as the industry grows, there's going to be a way to attack and solve those problems. There's going to be specific courses. There's LinkedIn courses popping up about specific AI topics that you could learn and elevate your skills. So I think some of these ways they're going to be able to change that. Now, when we're talking about operating model, so who are the key stakeholders that you need to be better aligned with? I'll talk a bit about, AI ethics committee or any specific other committees that you need to think about organizationally that you need to establish in order to have a common way to discuss those potential risks, discuss about how we can think and improve organizational alignment while adopting AI. We need to think about, is there a unified enterprise-wide process to deploy the new AI use cases? Are there multiple paths? How do you know which business use cases you should leverage first? So, I think there's an important thing we need to think about, how we remove the disconnect between senior leadership who says we just need to deploy AI to the actual operational level who actually makes the decisions of how we do that, how do we achieve that, how do we look at specific risks and how do we mitigate them, how do because obviously the main important thing is obviously all of these decisions are going to be made and based on risk methodologies, but we need to have a way to how we can highlight this to the business to make sure that correct decisions are being made. So have a think about, guys, what kind of operating models should be changed within your organizations, how they need to adapt to be nimble, to be able to live up with new AI speed. Now, if we look at change management, we're talking about, what is preventing change from occurring? How do you communicate expectations and performance to internal stakeholders? Again, we talked about AI explainability. Now, we need to think about how we can build metrics and how we can measure outcomes from AI. How do we achieve success and what do we class as success to internal and potentially external stakeholders? How do we erode our inertia? Are there any frameworks you can leverage? There are, ISO is coming up with ISO 42001. There's one of the AI use cases framework. There's ones popping up in America. There is OWASP Top 10. There's OWASP AI checklists that are appearing. There's some great information in there about, from different business units considerations, from legal considerations, from any other considerations that you need to be made from, supply chain and all of that, and also we need to think about, is culture an important lever or control in our AI adoption? So there's quite a lot to ponder, and obviously, again, we need to think about how these processes need to change and evolve while we're moving in this new world of AI space where things are going to change very quickly. We can't no longer operate in a waterfall type of project management space. We need to be very agile and move with the times. And lastly, decision support. So how much budget do you allocate to your AI security? If needed, how do you get additional funding? So you, again, as a CISO, you need to think about how you can procure AI security funding, what additional support you will need in your AI security journey. What is the role of compliance playing here? How do we comply with various regulations? We're talking about GDPR now. If you all of a sudden you want to deploy AI models to train on your PII, how does that landscape changes in compliance and regulation? How do you measure riskiness of your AI use cases? What about risk of third parties using AI? Now, how do you evaluate in your supply chain or your vendor assessment if they're using AI? Are you going to be risk averse or are you going to be risk very careful? So some of the decisions you need to be made. Do you need to update your due diligence supply chain questionnaires? Because, and you need to understand where, in what use cases AI is going to be using. Like, for example, is this business critical vendor? Is it okay if they use AI or it's not? How do you evaluate? How do you arrive with a business decision whether you agree with using that vendor or not. So there's going to be a lot of things changing, and again, you as a security leader, you should be the driving force to enable your organization to adapt to these changes and be the champion. I always said CISOs and security leaders always wanted more attention. They always wanted that seat at the boardroom table. Now this is your chance to drive that change, to become that person who leads organization to AI adoption with all of the knowledge that you have to empower this organization and become that trusted leader to get that seat at the table. Now, obviously, we talked about some of these controls. So there is a top 10 controls for mitigating AI risks. We're talking about from authentication and authorization, data and model encryption, data governance, model governance, and all of the rest. You can explore all of this to your mind. But important thing is to note is obviously risks are specific to specific use cases, so we can't just think about, oh, we just need to adopt all top 10. It all will depend on specific model use cases and specific things that you guys doing in your environment. We can't think and approach this as a sort of blanket statement. Now, again, we're looking about top controls for mitigating AI risks. So, it's just showing the coverage of, we talked about top 5 risks. So if you look at specific controls, you can see where there is an overlap from, for example, auditing and monitoring. We have an overlap between 3 or 4 risks. We talk about trustworthiness, Trojan models, model theft, prompt injection, and data poisoning. So there's quite a lot of overlap for you guys to explore and how some of these controls could be. We always say security should be defense in depth. So we should overlay some of these controls to make sure our models are secure enough to prevent threat actors and customers from exploiting our models. And I'll wrap it up. I just wanted to briefly touch on this very important thing. I kind of touched a bit about, we touched about trustworthiness, but it's very important to build your AI to be explainable. Now, what does that mean? We keep saying that AI is sort of black and opaque box that we can't really understand how it arrives to its conclusion and answers. So there are great papers now, if you guys research, called Shapley and Lime, which essentially talks about explainable AI. So Shapley essentially is Shapley additive explanation. So there's a specific framework that we can use in TensorFlow and all other frameworks and libraries to arrive and see how we can explain how specific data points. So you can see, for example, there's a graph about medical model that's looked at glucose, age, BMI, essentially to arrive at the decision who got diabetes and who hasn't. So you can see how specific data points are spread across the feature value graph, and you can see impact on model essentially output based on specific feature. And then you have Lime, which is local interpretable model agnostic explanations again. So you can see, for example, we look at patient number 8. It says model prediction that it is 72% that this patient has diabetes. Now, and then you can look at why it has arrived at this decision. So look at the feature and values. So it has 104 glucose levels. So anything glucose, as you can see in the middle, 99 and over, it increases the chances of someone having a diabetes. Now, secondly, again, we're looking at someone's blood pressure. If they have 70 and over, again, it increases the chances of someone having diabetes. And then we're looking at skin thickness again. So these are the main factors, how it increases or decreases someone's chances of having diabetes. And then obviously we can see how the model arrived to its decision. So some of these things, again, guys, to potentially look and explore in your model development. Look at Shap, look at Lime, look at explainable AI articles that allows you to think about, how we can showcase the privacy, robustness, trust, fairness, transparency, and imprintability on our models. So hopefully you guys, you love this journey. Just look at some of the, Databricks AI security framework, as I mentioned before. So it's made up of use cases, deployment models. We have 55 risks and 53 controls in total across 12 AI components to leverage and protect and protect essentially our models from specific risks. So hopefully you guys love the journey. Please like, subscribe, comment if you want me to explore any other use cases. But this is essentially the Databricks AI security framework. Hopefully you guys will learn something new about AI security, and you're going to be, guys, the leaders in how you're going to adopt AI in your organization, how you're going to detect and prevent certain risks in your organizations. So thank you for listening, guys. Come back for more on MP Cybersecurity channel.